So I'm going to give my talk in two parts, and I hope you all survive. And as I said, I really appreciate the chance to proselytize about HED. First part, I'm going to do HED concepts, and the second part, I'm going to go through some of the tools. After that, in the third talk, Young is going to demonstrate some of the annotation and go through some specific examples, more hands-on. So let's begin. We're a completely open source project. All of our stuff is online. All our code development is very visible and online. And there's some resources that you can go to find out everything, as well as contact us. So my first part of my talk is going to be organized into three parts. The first part is the basics of annotation. I'm going to talk about what a head annotation is, what terms you're allowed to use, what do you do if there's head vocabulary that's not in head. I try to give a justification for why you need a common vocabulary and why it's a schema and not an ontology. Then I'm going to go through head and bids and go through the basics. Some of you will be familiar with bids, but many of you may not be. And I'll talk a little bit about the interaction and issues with MOBI and bids. And finally, I'll talk about some more advanced concepts of annotation and how head context might be supported, especially in MOBI. So first thing, what is a head annotation? Well, head annotations are comma-separated lists of head tags. So sensory event, visual cue are examples, and they come from, they come from specified vocabulary called the head schema, which you see on the left. And you can reference a head tag by its path. So if you look at the right in the you'll see event, and under it you'll see sensory event and agent action. And sensory event is a child of event, and when you tag, you can give the full path, but we recommend that you just give the individual term, because head tools can translate it back to the path if needed. And all the head tags in a schema must be unique so that they each stand on their own. One of the key things about the way head schemas are organized is that each node is a subclass of its parent. So sensory event is an event. And the key reason that that's important is that searches for event also return sensory event. So because sensory event is an event. And this is important because when people tag, they may tag to different levels of detail. And this allows you to pick up items across the different experiments where people have tagged with different levels of detail. Another thing that's important to know is that head annotations themselves can be sentence-like, and we use parentheses to group things. So the agent is an experiment participant because that's grouped, and there's a sentence structure of subject and then predicate clause, and the predicate clause consists of a predicate and a direct object. So this kind of structure, if you tag that way, it almost directly translates into sentences. And if you look at the schema itself, they're noun-like items in the schema. They're verb item action. This action tree is a verb item. And then there's some description items. And this generally corresponds well to sentences. So let's start by saying, well, how do you annotate? And I'll give you a recipe. So here we have a task, which is we have a list of event codes, and we want to annotate those event codes. And the recipe is you start with what type of event it is. And this is a table that's in our documentation. This is sort of the first level kinds of tagging. And it gives you basically a lookup table. And so the first thing you do is you identify the kind of event. And then you identify the supporting tags. And if it's a sensor event, the kinds of supporting tags you might want are what kind of sense is being used, what the role of this sensory event is in the task, whether it's a stimulus, and what kind of thing it was that was presented. And then there's some example tags. So for example, non-WM turned out to be the presentation of a dash to get you to say, okay, get ready, we're going to start this memory task. And then it's a visual presentation, it's instructional, it's a cue, and the thing that was presented was a dash. Another example is the correct, and that's it gives a beep if you did it right. It's another sensory event, but it's an auditory presentation, and its role is feedback, and it was a beep. And you can parenthesize for meaning as before. So the second question is, well, what kinds of terms can you use? And the standard schema contains the terms that you'll usually need to annotate an experimental timeline. The basic description of stimuli, response, data characteristics, basic item characteristics, and it's organized as a sub-tag system. So it's groups of trees, and under each tree, it's a strict is a relationship. So you can extend those tags in most places. So for example, we have 2D shape, but if you don't have, you want to annotate a star, we don't have a star in our vocabulary, but you can write 2D shape /star, and searches will still pick up 2D shape. Now, beyond that, there might be a lot of other things you want to put in. And what we hope, and we've started to do, is develop library schema, which are just like library modules in programming languages. And these are developed by user communities, and there are several that have been developed or are under development. And they allow individual users, communities to standardize a group of terms specialized to their field. And they can add those terms as a library schema, and then they can anchor it either to any place in the existing HED schema or as subtrees of their own. But just by specifying the versions, they can provide a unified, standardized, specialized vocabulary that they can use in their for their community. And HED now supports lazy partnering, which means that as long as there are no conflicts, you can glom multiple of these libraries into a single schema. And there are MOBI library schemas under development, and I think that Yaya will say something about that when his talk, hopefully. So let's give an example of a score library. So the score library schema is the first one that we've had that's gone through the development process, and it's based on the score standard for neurological annotation by clinical neurologists for things like seizures and sleep disorders and things like that. And this is the example that it started out as an unpartnered schema. That means you had to use prefix qualifiers with it. But as the development of the score schema was underway, we realized that we needed to have it be partnered so that you could have this integration into a single schema. And so it now is partnered. And it's being used for clinical annotation, and it's a new version, with a substantial improvement in vocabulary is about to be released. So the idea is that communities can get together and propose a standardized vocabulary, and we have the mechanism for putting it into the larger community scope, and all the tools will then work with it. So a question is, why a schema, not an ontology? And we've developed the idea of a head information space. So when you annotate, I've done a lot of annotation, and I can tell you that the way most people annotate, and I've watched a lot of people annotate. So the way most people think about it is they kind of group things in general classes and then sort of say, okay, I got this. This is going to be a sensory event. Now, what am I going to say about it? And that's the way schemas are organized. They're subtag systems. It's a natural view for annotation and also for analysis, for searching and things. If you've ever tried to annotate with an ontology, you'll know that annotating with something complex with an ontology is really hard because it's a term-centric view and it's got all these links, and it's very hard to see what the big picture is. That being said, there's a very valuable part of having an ontology because it provides a knowledge graph of the bigger universe with links. It allows better provenance and allows additional information to be incorporated and associated with the terms in your vocabulary. And so very recently, we've been able to embed the head schema into a formal head ontology, and we hope to apply to the OBO Foundry to be accepted as one of their open ontology items. And this will allow us to provide additional links to the terms in our schema, which will allow us to do things like external help, and ultimately we hope to enable machine learning by having these links embedded in this. But this is work underway. We haven't formally released the schema, but we have the mechanisms now and are working through it for both the standard schema and the library schemas. Now, I'd like to also talk about why you need a common vocabulary, and Scott alluded to this somewhat. This is an example of 4 data sets that I've had a hand in annotating. And the first one is from Scott's lab, and it's the Sternberg. And in this example, the event codes are in a single column. They're named, they're not numbered, so that helps a little bit in understanding them. But you still don't know what those codes mean unless you very carefully read the paper. And the paper doesn't really say what GH means. And so you have to sort of know if you don't have head annotations. Here's another example from Scott's lab. This is the auditory visual attention shift. And here the event codes were coded in 2 columns. So the event code column has a different meaning depending on what the condition code is. Here's one from the Army, the BCIT driving. And here they had 4-digit event codes where the position in the code said something about the meaning, but you had to know what the key was in there. And later on, they did an experiment where they found that the 4-digit code wasn't enough because it was much too complicated an experiment. Each file had 20,000 events, and the details were extremely varying, so they went to a 5-digit code. So let's turn to step 2 part. So that's sort of the justification for why you really need to have common annotations, because it's impossible to understand what's in people's event files. And if you don't know what happened during the experiment, you can't analyze it in a reasonably accurate way. So I'd now like to turn to the how HED is integrated into BIDS. And we have a head validator, which is called as part of the BIDS validation. So it's very well integrated into there. If you have head annotations in your data, in your BIDS data set, the BIDS validator will validate the head as part of that. And we provide an NPM module that is integrated as one of the libraries into the BIDS validator. You specify the head version in the dataset underbar description JSON file, which is at the top level of your BIDS dataset, if you're familiar with BIDS. And there are two ways you can annotate using head in BIDS datasets. And one of the cases is you annotate each event individually. And this is good for things like artifact identification and signal features. But a more usual way of annotating is to annotate the unique event codes, which are common across the data set. And usually a typical experiment may use 20 or maybe 100 event codes, but there are likely thousands of events. So there's a big difference between annotating individual events and annotating event codes. And you can use combinations of these. And there are tools to support annotation regardless of how you approach it. So let's take a look at how that goes. And I'd like to look at an event file in more detail. So BIDS represents events, which are really event markers in the experimental timeline, as tab separated value files, and they end in events.tsv. Each row represents an event marker, and the first column is the time of that event relative to the recording, which is associated with this event table. And BIDS requires onset and duration columns, and you can add other columns. And people are sometimes confused. They think that trial type and value columns are required in BIDS, but they're not. You can add any columns you want beyond onset and duration, which are required. Now, the way that BIDS works is that the metadata for the experiment, including what the events are, is stored in a JSON file, which ends in, for events, events.json. And here's an example. And it's a dictionary. The top level things are the names of the columns. And BIDS, if you don't use head, there's still levels. You're supposed to describe what's in what each of the codes means if you are not using head. But if you're using head, you should do both. And if you're using head, then you have under the column name, you give a head dictionary that says what these things mean. And this is just dummy annotations, which were generated by our template generator, which I'll show shortly. So let's go through the process of annotating with head in BIDS. So you start with an events.tsv file, and it may have a head column, which means that you're trying to annotate individual events in this file, and that's fine, or not. But for columns that you want to annotate as a whole, you extract a dictionary of the unique values, and it's going to be in an events.json file, and you just usually need one of those that you put at the top level because people use common event codes across all the recordings in their data set. Then you fill in the head annotations for the data, and we have tools for that. And then at analysis time, the head tools take what's in the head column, if there is one, and assemble event annotations for each event marker, which can then be used for analysis or summary. And you can search for events and do other things, create factor vectors, and extract design matrices. or do visualizations. Now, one of the important recent developments is that head annotations can be incorporated using the same mechanism into most of the common metadata files, tabular files. So you can head annotate the participants, the samples, the scans, the sessions, and the phenotypes files. And head tools can validate those and be able to map them into the experimental timeline for doing searches and other kinds of analysis. So the question is, well, does BIDS support MOBI? Well, Sane and Julius have worked very hard and gotten the motion BEP into BIDS, and it was completed in 2023. And I'd like to congratulate Sane and Julius on this very arduous and long task. There's eye tracking, which is it's been around for a very long time, and supposedly it's close to PR submission. I think it would be a very valuable contribution to BIDS and hope it will be done. And Yaya has started an EMG BEP, and I'm hoping that that goes forward. He just started it, but this is very, very relevant to MOBI. But the problem is, BIDS, I think BIDS has a time problem. The way BIDS is organized, each type of data has its own directory. And so simultaneously recorded data must be split into separate directories, and the events for each type of data are stored in that directory with the data. And the event markers in the events file are assumed to be relative to the start of the recording. And here's where things break down. So things like for motion may have a latency channel which gives the time markers, but you know, there's no necessarily mechanism to have those time latencies be relative to a global clock. And so, you know, I think this is really a problem. It's suggested, but not required, that users include an acquisition time column in the optional scans TSV column, but surprisingly few BIDS data sets that now exist do that. So very few BIDS data sets that are deposited in OpenNeuro actually have starting acquisition times. Some data modalities have a time embedded in the actual recording data, but there's nothing in the metadata for a lot of these data sets. Now, IEEG is now allowing a Neurodata Without Border NWB format for storing their data, their recording data. And that actually has a global timeline embed and all the data relevant to a recording session embedded in a single file with a sync to a global timeline. But I think this is really a problem for MOBI and for multimodal analysis in general. And I don't have an answer for that, but you know, I think as more people want to put MOBI data into BIDS, I think this will be important. So here's the summary. So HED isn't really supporting MOBI to motion to the extent that we want to. And we thought this would be a really good forum for us to at least introduce you to HED and hope to get some interaction with your community to see how we could best support head annotation in motion data. So BIDS has several kinds of TSVs in addition to events. It has motion TSVs and it has channel TSVs. HED doesn't, tools currently aren't looking at those in any validation or analysis, but we very well could if we knew what to do. And so our questions are, how will events be used in motion data, and what kinds of information do people who analyze motion data want mapped to the experimental timeline? And how should we map a global timeline for mapping event context? Because in MOBI data, you often have multiple rigs and multiple experimental timelines. And, we want to be able to insert HED into there and in a way that's usable to the community. So we need input and suggestions. So the key points are, here are HED are tags, that they're organized in a hierarchical structure. Tags are unique. The vocabulary follows a strict is-a relationship, and that means that searching for a general term will also return annotations that are more specific. And you can extend tags. The preferred method of annotation is using a sidecar, because it's a lot of work to annotate individual events, and but you can do it, and you can use a combination of all these events. And the final thing is that event annotation is a iterative process. And so if you just put the kind of event as a single head tag in your tags, that's a start, and that gives some information. And then as things proceed, you can make your annotations more detailed just by editing a text file. And so now what I'm going to do is to explain some of the HED's more advanced features and how to use them. And as Scott mentioned, this is very much related to the event marker representation of event processes. So here are some different experimental timelines which show how HED annotations at event markers can then be mapped into event processes on the timeline. And the top timeline here shows how to use a duration tag. And here at a duration, at a marker, you can just say what the duration is. And then in parentheses, you can put a bunch of head tags and say, okay, this is an event and this is how long it lasts. And then as far as the head tools are concerned, that automatically sets up an event context. So if you select a point in the timeline in this blue oval, and you ask, well, what's happening at that point? I want to take into account event context. It will tell you that whatever label X represents is going on at that point. And these duration tags don't require any other kinds of definitions. You just plunk them down and use them, and they can overlap, and there's no problem with that. For more sophisticated annotations, we use the onset offset item, and here you define what the event processes are, and you then group it with an onset tag, and you can specialize each one of these to say, well, there's this additional stuff going on for this one. So label X means that this first event process has whatever label X is going on, whereas the second one has this other stuff label Y going on, but they're actually this kind of event. And there are other ways of indexing and numbering the events, so you can give one definition for a single class of events and have a lot of them going on at the same time with specifics for those events. These kinds of event processes can be ended either by having another onset of the same kind or by having an offset. And then, as Scott mentioned, we also have phase markers, and this might be particularly relevant to MOBI, where you have motions, but there are lots of intermediate things going on that you might want to annotate, but not say that this is actually a whole event process of its own. And that uses the inset marker, as shown in the blast timeline. So, as mentioned before, one of the important consequences of being able to put head tags in metadata such as participants is that that allows us to gather annotated metadata and map it into the experimental timeline using the concept of a recording event process that starts at the beginning and ends at the end, and makes all of the metadata that is head annotated available at any point in the timeline for searching or whatever. And so this is is where the context information is going. And hopefully this will be very useful in downstream analysis. So I'd like to just do a little bit more specifics, since I have some time remaining, of some of the more advanced ideas of HED and how you annotate. And a good example is the way you annotate experimental conditions. And there's several ways you can do it. One of them is with direct annotation, and that's just saying, okay, this guy's an experimental condition, use this condition tag. And so here's an example. You see the face type is in this events column, and we want to treat it as an experimental condition. And this shows the JSON file excerpt. And you just say, okay, it's a condition variable, and I'm going to call it famous face. And you can call it anything you want. And I'm going to say, when you see the word famous face in the face type column, then you can say that has a condition variable famous face. And these are user selected names. And this is a really easy way to annotate condition variables in your events file. It's easy and it's included in the summaries. But one of the problems with easy is there's no free lunch, and you don't get levels and design matrices out of that. And there's some other things that you can't use the full features of HED if you just do direct annotations. So, of course, there are other ways to do that. And here's an example of the experimental timeline that Scott showed. And this actually shows the three experimental conditions. And they are represented in, well, the face type is represented in the face type column. The repetition is in the repetition rep status column, but this key assignment isn't in the events file per se. It turns out it's an experiment recording wide experimental condition. So each recording has a different one of these. And you'll see that it's in the, so here's face type, repetition type, but the setup is in the first row of the event file. And so this is just recorded as an event marker unless you annotate it with an onset saying this is an event process. If you do the event process, then it's available to the entire experimental timeline. So let's look at how that happens. You define this as famous face, and you give the definitions. Here are the definitions. And then you create a definition variable. And then if you use onsets and offsets, you can get out the design matrices. And we'll look at how that goes a little bit. So direct, you just use a condition variable tag like this. And when you get a summary out, if you look at it, it's just treating each one of these as a separate tag. So for example, the famous face condition, if you look at the bottom, it appears 5,304 times out of a total of 63,000 events, and it's direct. It's just, that tag is just sitting there. That's what direct files means. However, if you use definitions, then you have definition famous tag and definition unfamiliar tag. And when you tag it, it shows up like this. And so it has, you'll notice that in the condition, the definition, what it's saying is that famous face condition has a condition variable face type. And so when you annotate this way with the condition variable being in the definition, it treats famous face as a level of the design variable or condition variable face type. And so then you get a face type condition variable, which has levels unfamiliar face, familiar face, and scrambled face. And then from this annotation, you can then automatically extract design matrices. So with onset and duration, you do the same thing, except that when you do the setup left sim, you just group that definition with an onset. And as long as there's no offset appearing in the event table, that onset will continue, that event process will continue to the end of the experiment. So if you don't use the onset and offset, as in this first example, you'll see that for left sim condition, there were 48 direct references, and there were 48 references, that's the events, in 48 files, which means there was one per file. And it's only picking up the fact that this was annotated at the first, as an event marker on the first line of the events file. But if you simply include the definition, then you get a key assignment variable, because I've defined it as a key assignment, and you get condition variables. Now, this is, remember, this summary is done across all of the event files in the data set. So you're then able to extract the design matrix from these point events as well. So the key takeaway here is it's important to think about the difference between an event process, which is an ongoing process with a start and an end that has a context, and just a simple event marker, which is just a point. So the big picture, events are central to many of the analyses. They provide a direct, and HED provides a direct framework for annotating and manipulating and analyzing events. One important thing that I haven't mentioned so far that is it's really hard to determine all the ways that an event file might need to be used. And the way an event file is organized will determine how hard it is to analyze it. And for different analyses, you might need the event files organized in a different way. And so we view event files as not being fixed in stone, but having fluidity. And as I'll show in my next talk, we've created a remodeling tool suite. And one of the things, the reason it's called remodeling is because it provides a lot of event file transformations to put things in columns, take columns out, rename columns, remap multiple columns to suit an event analysis that you want to do. But, sorry, if you don't put in the event markers, or you encode them ambiguously, or you don't report them at all, there's little hope of fixing it. And we have lots of tools And I'll talk about those tools in the next section. So here's some, or sorry, here are some links to our GitHub organization and our homepage. And from there, you can get at all the links that you need. And again, we're completely open source, and we would be happy to collaborate on your data or on your vocabularies.